All right, I'm going to be working through this, so if it's helpful to watch, please do. And if you want to skip ahead to specific problems to get some extra help, you can do that as well. I do recommend trying the problems you can beforehand and then maybe using this as an extra support. So a few things kind of at the beginning here just to make sure that we know our basic facts. So let's see. If we have a central angle, so the measure of angle ABC, so that's this measure right here, we know that that's the same as the measure of the arc that angle intercepts. So we know the measure of this arc and the angle are the same. If it's an inscribed angle, right, which means the vertex of the angle is on the circle, then we know that's going to be 1/2 the measure of the arc that it cuts out. That's the inscribed angle. So that's half as big as that arc. GLK, so this angle right here, it's inside, there's a rule that says that that is equal to the average of these two arcs. So these two arcs, if we add them up and divide by 2, we get that angle. So we could say the measure of arc GK plus the measure of arc JH divided by 2. So that gives us the average of those two. And then if you have an angle outside, this angle right here, it is simply going to be the larger arc minus the smaller arc divided by 2. So that's going to be equal to the measure of arc RM minus the measure of arc QN, all divided by 2. So these are the relationships between angles that we kind of need to know, or we need to know. Then there's some relationships with line segments, basically. So chord says that essentially A times B is equal to D times C. That's probably the simplest of them. Secant says if you take the exterior portion of one secant and multiply by the entire length of that secant, you get the exterior portion of the other secant times the entire length of that other secant. So remember that it's always exterior times entire length. That's kind of the important thing to remember about the secant product theorem. And secant tangent product theorem, it's the same thing as the secant, except for because you have a tangent, you just square its length. So if you take the length of your tangent and square it, you get the exterior portion of your secant times the entire length of the secant. Okay, so those are kind of some of the main things we need to know about circles. All right, to inscribed angle CDB, and angle CEB of circle A are shown with the associated arc BC. Okay, find the measure of CDB. Well, since the central angle is 110, I know the measure of arc CB is also 110 degrees. And since CDB is an inscribed angle, I know the measure of angle CDB is going to be half of that arc, which is 55 degrees. I also know that the measure of angle CEB would also be 55 degrees because they're both inscribed angles, so half the measure of the arc. Quadrilateral WXYZ is inscribed in circle O. Find the measure of angle X. Remember that for an inscribed quadrilateral, these two angles are supplementary. And the angles Z and X are supplementary. So I can say that 11m minus 12 plus 8m plus 2 is equal to 180. So therefore, 19m minus 10 equals 180. 19m equals 190. M equals 10. So if m equals 10, then I know that the measure of angle, well, let's see, I need to find the measure of angle Z, because if I know Z, then I should be able to find X, since Z and X are supplementary. So the measure of angle Z would be 10 times 10 plus 3, which is 103 degrees. So the measure of angle x is going to be 180 minus 103, which is 77 degrees. So the measure of angle x is going to be 77 degrees. And that seems like a reasonable answer based on what my eyes are telling me. Circle O has a radius of 3. Okay, so this is 3, that's 3, and that's 3. Tangent segments are drawn from circle A, from A to circle O. Find AB. Okay, well, basically, I know that if I have two tangents drawn from the same point, they are equal. So AC, or they have equal length, is equal to AB. Therefore, 8x minus 1 equals 5x plus 14. So 3x equals 15, x equals 5. The length of AB is equal to 5x plus 14, which is going to be 5 times 5 plus 14, which is 25 plus 14, which is 39. So the length of AB is 39, so is the length of AC. We didn't really even need to know the radius for this problem. Okay, we got some vocab here, which I'm going to let you complete because you can always just look in your textbook. Okay, given that the measure of angle ABC is 38 degrees, ABC, so this is 38 degrees. Determine each angle measure and justify your reasoning. ACB. Okay, ACB, so what I know is that this is a radius AB, and this is a radius AC. So by the isosceles triangle theorem, this is also 38 degrees. By isosceles triangle theorem, since AC is equal to AB, both radii of the circle. Okay, the measure of CAB, well, I could just find that by using the triangle sum theorem. 180 degrees minus 38 degrees minus 38 degrees. So I think that's 180 minus 76. So that's going to be 104 degrees. That is the triangle sum theorem. Okay? And finally, the measure of angle CDB. Okay, CDB. So that's an inscribed angle for arc CB. I know arc CB must have a measure of 104 degrees because that's the measure of angle CAB. So this must equal 104 divided by 2, 52 degrees. That's the inscribed angle theorem. Okay. Circle S, an angle is inscribed along a diameter. Okay, anytime you see a diameter, you know that this arc right here is going to be 180 degrees, and this arc is going to be 180 degrees. So since that's 180 degrees, this has to be 90 because angle P is an inscribed angle for arc QR. Okay, the measure of angle PQR right here is 2x minus 2 degrees. Measure of angle QRP is 3x plus 12 degrees. Determine the measures of all three angles. So since this is 90 degrees, I know that 2x minus 2 and 3x plus 12 are going to have to add to 90 degrees because all three of them have to add to 180. So if I subtract off the 90, I get 90. So that means 5x plus 10 is equal to 90. 5x equals 80. X equals 16. Okay, my iPad is lagging a bit. So if x equals 16, I know that the measure of angle PQR is equal to 2 times 16 minus 2, which is 30 degrees. I know that the measure of angle QRP is going to be 60 degrees. 3 times 16 plus 12, wait, yes. 60 degrees. And I know, of course, that the measure of angle QPR is 90 degrees. Okay, so I'm going to have to erase some things here in order to give my iPad a little rest. So I'm going to erase this and scroll up and erase some more things here. Otherwise, I run into some issues. So, of course, you can fast forward this if you want to. Okay, let's see if that helps. Okay, where were we? 19 and 20, and then we'll take a break and maybe do a new video. So 19, Jasmine plants a circular garden. She places stepping stones along line segment AC and BD, giving AE is 11 feet, EC is 9 feet, EB is 7 feet, find DE. Okay, well, I just know that if I'm going to call DE x, so x times 7 is equal to 11 times 9, which means that 7x is equal to 99, and x is going to be 99 divided by 7. I want to round that to the nearest foot. I would get 14.14, so that's approximately 14 feet. Jasmine is planning to place a statue at E. Okay. Given the measure of AD equals 15 degrees, okay, 15 degrees, this arc, it seems a little small, but okay. And the measure of arc BC is equal to 9.8 degrees. Find the measure of AED. So I know that the measure of angle AED is the average of those two arcs. So I can do 15 plus 9.8 and divide it by 2. 15 plus 9.8 and divide it by 2 to get 12.4 degrees. Doesn't seem like this is drawn to scale, but I think that's what we would get. Okay. Number 20. Okay, Jasmine's cousin also plants a circular garden. He builds a tool shed at point J. Given HM is 18 feet and JH is 4 feet, find the distance from the garden at point K to the tool shed. Okay, so this is the secant tangent, which says that the square of the length of the tangent is equal to the exterior portion of the secant times the entire length of the secant. So x squared is equal to 88, and therefore x is the square root of 88, which is approximately equal to 9.38. So we're going to say approximately 9 feet, since it says round to the nearest foot. He places a spotlight on the corner of his tool shed. Given the measure of arc MK is 135 degrees, and the measure of angle KJM is 24 degrees, find the amount of the garden's edge illuminated by the spotlight. So that would be this right here. Okay. So to do that, we can say, we know basically that if you take the longer arc, subtract the shorter arc, which is what we want to find, and divide by 2, you get the measure of that angle, which is 24. So 135 minus the measure of arc KH is equal to 48, which means that the negative measure of arc KH is equal to 48 minus 135, which is negative 87. So therefore, the measure of arc KH is equal to 87 degrees. So 87 degrees of the garden's edge. All right, I'll just keep rolling here since the thing seems to be doing better. Okay, a fountain with a circumference of 300 feet has several points of interest. Given a measure of DMA is 84 degrees, and the measure of arc DA is 72 degrees, find the measure of arc EC. So I know that the measure of arc EC plus the measure of arc DA, which is 72 degrees, if I average them, I get the angle in the middle. So the measure of arc EC plus 72 degrees equals, multiply by 2, 168. The measure of arc EC is equal to 168 minus 72. And 168 minus 72 is 96 degrees. Given the measure of ET, arc ET is 85 degrees. Okay, so that's 85 degrees. And the measure of arc AT is 155 degrees. Find the measure of angle S. Okay, so this looks like a tangent and a secant. I know that the measure of angle S is equal to 1/2 the difference of those two. So I can do 155 minus 85, which is 70, divide it by 2, and I get 35 degrees. Again, that's because if I have this angle here, a tangent and a secant, this angle right here is always half the larger arc minus the smaller arc. So that's where I'm getting 35 degrees. Okay. The wall of the fountain along arc TC, okay, so right here, along right here, needs to be repaired. Given the measure of angle STC, so that's this angle right here, is 69 degrees, what length of the fountain wall needs to be repaired? What length? Okay, so let's find the measure of that arc. The measure of that arc is just going to be twice 69 degrees, and that's 138 degrees. So 138 degrees is the measure, and that's because if you have a circle like this with basically you know, something cutting like this and then a tangent going off, if this angle is 69 degrees, this is going to be twice that, which is 138 degrees. So I know it's 138 degrees, but I want to find the length. So since the circumference of this is 300 feet, I can basically do 138 divided by 360 and multiply by my circumference, and that's going to give me the length, right? 138 divided by 36 times 30 would be another way to do it. So I will do 30 divided by 36 times 138 is 115 feet. So I basically just took my circumference, multiplied by the proportion that I had, and I end up with 115 feet, which if it's 300 feet around, makes sense that it would be a little bit less than half. All right. Notice it's not asking for the measure of the arc there. It's actually asking for the length, which is why I had to find the actual length. All right, find the area of a circle with a circumference of 18 inches. Okay, if the circumference is 18 inches, then I can set that equal to 2 pi r. So that means 18 divided by 2 pi is my radius. If I want to find the area, that's pi r squared. So that would be pi times 18 over 2 pi all squared. It says round to the nearest tenth. So I'm going to take 18 divided by 2, I get 9, divide it by pi, I get 2.86, then I'm going to square that, and then multiply by pi again, and I should get about 25.8 square inches. So I use the formula for circumference to find my radius. Once I have my radius, I just plug it into my formula for area. Find the circumference of a circle with an area of 25 pi. So if the area is 25 pi, I can set that equal to the area formula, which is pi r squared. You'll notice that my pi's can divide out of both sides. And then I'll end up with 25 equals r squared. So my radius must be 5. So therefore, the circumference is 2 pi r, which is going to be 10 pi meters. Leave your answer in terms of pi. Check. Round to the nearest tenth. Check. Okay. Convert each angle from degrees to radians or radians to degrees. So 80 degrees, I'm going to multiply by pi radians divided by 180 degrees. That's 8 pi over 18 divided by 2, 4 pi ninths radians. To multiply this or to convert this into degrees, I'm going to multiply it by 180 divided by pi. Pi's will divide out. Now I get 5 times 180 divided by 6. I'm going to divide by 6 first and get 5 times 30, which is 150 degrees. So you're always going to multiply by 180 over pi or pi over 180, depending on which direction you want to go. Okay, let's erase. Okay, we're getting there. Approximate each shaded sector area and corresponding arc length. Okay, so I'm finding the arc length and the sector area. So the sector area here would be 100 divided by 360 times pi r squared, which would be 4 squared, which would be 16. Of course, 100 over 360 is the same as 10 over 36 times pi times 16. It says to round to the nearest hundredth, so I'll do 10 divided by 36 times 16 times pi, and I end up with 13.96 centimeters squared. That's the area. Now, if I want to find the arc length, that would be this length right here, then I would need to do the same proportion, 100 over 360 times 2 pi r, 2 pi times 4. So that would basically end up being 10 over 36 times 8 pi. So it should be half of the number that I got before, but I'll just double check it. I got 6.98. Different units though. This is 6.98 centimeters because that's just the length of this arc right here, right? Just the length of that arc. Okay. For this one, looks like we're dealing with 335 degrees. So we would do 335 divided by 360 times pi times 10.5 squared. This would be the sector area. And for the arc length of that whole thing, we would do 335 divided by 360 times the circumference, which is 2 pi times 10.5. So let's get a decimal approximation for each of those things. So for the area, I got 322.31 inches squared. And for the arc length, I got 61.39 inches. Okay. So 45, security cameras attached in the corner of a store building. Okay. Cameras guaranteed to see with a radius of 100 feet. Okay. It rotates around an arc measuring 245 degrees. Okay. What distance around the perimeter of the building does the security camera cover? So I guess they're talking about this distance right here. A little bit confusing what distance around the perimeter of the building does the security camera cover, but I guess we'll call it that. And so that would basically be the arc length. So we would take 245, divide it by 360, and multiply by the circumference of that circle, which would be 2 pi times 100. So if we do that, we get 245 divided by 360 times 200 times pi is 427, or sorry, 428 feet. Josiah is designing a mural for a contest. The mural consists of a circle with a radius of 3 feet in which he sketches the central angle of 65 degrees. Okay. Josiah intends to paint the sector purple, but paints only 1/4 of the sector before he runs out of purple paint. Okay, so he has this sector here, 3 feet, paints only 1/4 of it purple. I know that's not purple. And so what is the unpainted area of the sector? So I'm looking for this red stuff. So remember that the whole angle here was 65 degrees. So what's left is 3/4 times 65 degrees. So that'd be 65 times 3 divided by 4, which is 48.75 degrees. So that's the amount of the red sector. So to find that, I would do pi r squared, which is 9 pi, that's the area of the entire circle, then multiply by 48.75 over 360. So if I do that, I get 3.8 square feet. Okay. 47, we're getting close here. The window, a window is in the shape of a circle and divided into 12 equal sized sectors. Okay. So there's 4. So then if I cut this into thirds, I have 12 sections. 5 of the sectors are tinted blue. 1, 2, 3, 4, 5. The diameter of the window is 50, so radius 25 inches. What is the area of the window that is tinted blue? Okay, so, well, I need to know what the measure of this angle is. Well, that's really just 5/12 of the circle. So I could essentially just take the entire area and multiply by 5/12 is probably the best thing to do. So 5/12 times pi times 25 squared would be the area that is tinted blue. So 25 times 25 times pi times 5 times 12, which is 117,800 or 810 to the nearest square inch, inches squared. Alrighty, I'm going to go ahead and erase, and we'll finish this off. All right, number 48, find AB. All right, well, what I know is that if I take the tangent length squared, that's equal to the exterior portion of the secant times the entire length of the secant. So I should get x minus 3 squared equals x minus 5 times x. So x squared minus 6x plus 9 equals x squared minus 5x. Lucky for me, the x squareds can be subtracted from both sides. I get negative 6x plus 9 equals negative 5x. Add the 5x, subtract the 9, I get negative x equals negative 9, so x equals 9. So if x equals 9, AB equals 9 minus 3, which is 6. By the way, if that's 6, then I know that CB would be 9 minus 5, which is 4. So I could check and see, is the exterior part of the secant times the entire length of the secant equal to the tangent squared? Yes, 36 equals 36. So that works. Find JL. 2 secants. The exterior portion of one secant times the entire length of that secant is equal to the exterior length of the secant times the entire length of that secant. So x minus 2 times 2x minus 2 equals 8 times 14, which is 80 plus 32, which is 112. Yes. Okay, I'm going to erase some things here so that this thing doesn't freak out too much. Okay, so distributing 2x squared minus 2x minus 4x plus 4 equals 112. 2x squared minus 6x minus 4 minus 112 is 108 equals 0. Divide everything by 2. X squared minus 3x minus 54 equals 0. Now I know that I can factor this. You could also complete the square or use a quadratic formula, but I know that two numbers that multiply to negative 54 and add to negative 3 are negative 9 and 6. 6 times 9 is 54. So that means my solutions are either x equals 9 or x equals negative 6. Negative 6 isn't going to work because I can't have negative answers. So if x equals 9, then JL, which is the entire length of that secant, is 2x minus 2, which is 18 minus 2, which is 16. Okay, last problem. Find the measure of angle TUW. Okay, that angle is equal to the larger arc that it intercepts minus the smaller arc that it intercepts divided by 2. So 28x is equal to 39x minus 55. So 28 minus 39 is negative 11x equals negative 55. So x equals 5. So if x is 5, the measure of angle TUW, which is right here, that the measure of that angle is 14 times 5, which is 70 degrees. And that's it.